Hello students, welcome to the new session of this chapter. In this session we will discuss about the mass and the weight. So first of all I'll discuss about the mass. So students, the mass of an object is the measure of its inertia. That is why greater the mass, the greater is the inertia. And students, mass of an object is constant and does not change from place to place. In the entire universe, your mass will be constant everywhere. For example, if your mass on the earth is m, it means at any planet or at moon your mass will be m. There will be no change in your mass because mass is the constant property of the object. Now let's discuss about the weight. So students, we know that F equals to mg. Here F is the force, m is the mass of the object, and g is the acceleration due to the gravity. And students, if we are talking about the weight of an object on the earth, then the force of the attraction of the earth on an object is known as the weight of that object. So we can replace the F by the W. Now we can say that the W, that is the weight, will be equals to the m into g, that is mass into acceleration due to gravity. And the SI unit of the weight is Newton, and weight depends on the g. It means if your weight on the earth is W, that is capital W, then it is possible your weight on the other planet or on the moon will be different. That is why I'm showing your weight on the moon by small w. So students, from the concept of weight, we can understand that our weight on the earth and on the moon will be different. But the question is, how can we measure that difference in our weight on the moon? So let's discuss the weight of an object on the moon. So students, we know that F equals to g mm by r square. And we can modify this formula if we are talking about the earth. In this new formula, We is the weight of the object on the earth, Me is the mass of the earth, and Re is the radius of the earth. Whereas G is the same, that is universal gravitational constant, and M is the mass of the object. We can also modify this formula if we are talking about the moon. In this formula, Wm is the weight of the object on the moon, mm is the mass of the moon, and rm is the radius of the moon. Now I'm going to put all the known values in these formulas, that we will have We for the earth and Wm for the moon. And after putting the value of mass of the earth and the mass of the moon, I'll solve this equation and I'll divide Wm by We, and that value will be roughly about 1 upon 6. So we can say that Wm upon We will be 1 by 6. So students, now we have this value, that is Wm upon We is equals to 1 upon 6. But the question is, what is its significance? So students, from this equation we can write that Wm is equals to 1 upon 6 We. Let's understand this. Suppose your weight on the earth is 60. So now my question is, what is your weight on the moon? So now from the help of this given formula, you can easily calculate your weight on the moon. For this, you have to divide your weight on the earth by 6. So if you divide the 60 by 6, you will have 10. That means your weight on the earth will be 10. So students, you have to remember this relationship. So class, I hope you understand the concepts covered in this session. After this session, please read the NCERT book and complete the given assignment. Thank you.